Hi. In this second and last presentation addressing data level parallelism, we will look into graphics processing units or GPUs, and we will continue to follow the Patterson and Hennessy's Computer Organization and Design book. After watching this presentation and completing the learning task proposed at the end, you should be able to explain how GPUs differ from traditional CPUs, the importance of multithreading in GPU architectures, and finally you should be able to explain the role of the main blocks in a simplified data path of a multithreaded SIMD processor. The original justification for adding SIMD instructions to existing architectures was that an increasing fraction of processing time was used for graphics. As the graphics processors increased in power, they became known as graphics processing units or GPUs to distinguish them from CPUs. This also means that GPUs do not need to be able to perform all the tasks of a CPU, since they are used as accelerators that supplement a CPU. GPUs, therefore, have specific styles of architecture. Perhaps the biggest difference is that GPUs do not rely on multi-level caches to overcome the long latency to memory, but instead they rely on hardware multithreading, that is, between the time of a memory request and the time that data arrives, the GPU executes hundreds or thousands of threads that are independent of that request. So memory bandwidth is more important than latency, and MIMD architectures play an important role in GPUs. NVIDIA is probably the best known company designing GPUs for the gaming and professional markets, and their CUDA programming language is widely used. When a GPU is used to accelerate program execution, the compute-intensive portion of the application runs on thousands of GPU cores in parallel, while the sequential part of the workload runs on the CPU. Earlier this year, the company launched its first 2 petaflops. A petaflop is a unit of computing speed equal to 10 to the power of 15 floating point operations per second. It launched its first 2 petaflops machine and announced it as the world's most powerful AI system. You may like to see this 2-minute promotional video where their director of product marketing, artificial intelligence and deep learning talks about this unit that combines 16 V100 GPUs. GPUs and vector architectures work well with data-level parallel problems, but GPU processors have even more registers than vector processors. As we said a while ago, GPUs overcome memory latency through hardware multithreading within a single multithreaded SIMD processor. This type of processor is similar to a vector processor, but has many functional parallel units instead of just a few that are deeply pipelined. This slide shows the simplified block diagram of the data path of a multithreaded SIMD processor comprising 16 lanes. A GPU comprises a collection of these multithreaded SIMD processors, and an upper-level unit called the thread block scheduler is in charge of assigning blocks of threads to these units. To conclude your theoretical study in this subject, please read the section entitled Putting GPUs in Perspective, which is presented in pages 529 to 531 of the book. And this ends our presentations on data level parallelism. Thanks for your attention.